Is anyone here a member of Dubai Blockchain Center? Not directly?
No, I'm from Europe. So.
You're from Europe, okay. Well, the reason why I asked that is this is not exclusive. You're welcome to be here, obviously. But one of the things that we have done is a collaboration with Dubai Blockchain Center for like an education series. And this is kind of a smaller part of one of our larger modules that we do with them. And this is like the second part of it. We had the first part 3 weeks ago, and the second part is now. And it's also under Cardano Academy. And Cardano Academy is an education initiative from Cardano Foundation, which is basically creating high quality, free education to help people and organizations understand blockchain technology and also applications and real world solutions. We're implementing something called Slido. And so this is for like live feedback during the event. And if you wish to scan the QR code on your mobile phone, I will take all your personal information. Okay, that's just a joke. We're live here on this side, okay? But yeah, it helps with live Q&A. Or we can just speak and ask questions at any time. So Cardano Academy, yes, as we have different courses. One of them is for a certified blockchain associate, which is around, I think, 60 hours of content for having quality verified and up-to-date information, where we have looked at several university programs and we've seen some of the pitfalls that they have, where we've added this to Cardano Academy, and we'll be continuously building out new courses and collaborating with ecosystem partners. One of these organizations that are using Cardano Academy today is Petrobras. And Petrobras, this is being rolled out to 40,000 of their employees. And the purpose for them is the fact that as they're exploring different blockchain solutions, they see the value in upgrading their internal teams with general education. We also have like a certified course with Pearson VUE. And if you'd like to get yourself certified, this is a ticket for 50% off before November 30th. And it's like a 50-question test. And it takes maybe 2 hours to go through fully, where you can go to any Pearson VUE center for this course. And if you want the promo code at the end of the session, please let me know, and I will share it with you, no problem. So yes, Cardano Foundation and Dubai Blockchain Center. One of the founding statements from Dubai Blockchain Center is to bring your impossible to Dubai. And what that means is that, here's where we can try to leverage the opportunities for further development with new innovations and new technologies. And in this section, we're going to be going into verifiable supply chain data and what are these kind of building blocks to deliver, and go through a use case to see how that gets functionally deployed. So my name is Jeremy Furster, and I am the Global Enterprise Adoption Lead at Cardano Foundation. And mainly what I do is I work very closely with our engineering teams to think about this problem and understand, what is the market infrastructure required to solve this, as well as the technical capabilities of the Cardano blockchain. And what I'm going to discuss today with you, for me, represents best practices with certain paradigms for openness of data and third-party verification. That for me is a core value of why someone should be using a blockchain. And part of that, when we think about why, is also how. And on the how side, there is a lot more today dealing with data compliance than ever before. And part of that is that if you put something out on a blockchain, well, you may be liable if someone wants that information taken down. So data privacy is also then a core component here to data verification, but then that doesn't make sense. It's two competing odds with one another. Or is it? And that comes down to thinking more concretely about how it is that we can design our solution that is encrypted, but still remains, verifiable. And that's a link to off-chain data storage layers. But yes, so let's first think about an apple. Now, all of us on the left, if we were to see an apple in real life, we would instantly know so many details about this apple, especially if we go into a store and now we're ready to buy it. But on the right side, when it becomes digital, we start to communicate about apples very, very, very differently. So one of the open questions here is, okay, if we have a digital apple, what information do you think we might want to add to, enrich its description? And I don't see anyone typing on Slido, so that is okay. But maybe I can just ask, and if you want to shout something out. So if we have a digital asset, if we're building something on a data record, what type of information would you commonly expect to describe an apple? Okay, a data hash of the representation.
The family, is it Honeycrisp or what kind of?
Yes, Honeycrisp, provenance data. Very good. Let's see if anyone's typing anything. One participant. All right, this is going to take a while. We might skip through it. There you go. Maybe we'll put that on the blockchain, and then we were good. Yes, color, data production, maybe who it is that produced this apple.
GMO or non-GMO?
Yes. Fair labor practices might be something we want to know about an apple. If it was made following SDGs that are, where we want to be following industry norms. Yeah, pesticides. The list can go on and on now when we start thinking about this. And we can actually start thinking about this a lot more in a way that's looking at what's called the Pareto principle. This is a very, very old way of thinking, but basically this is like having an 80-20 rule, that if you do like 20% of the things correct in any given category, that's going to take care of 80% of your results, right? They also say that 20% of your customers is 80% of your revenue. And sometimes when we think about technical features, 20% of what you build out covers 80% of all use cases. And so with that type of thinking, we kind of come in here to see about, okay, so what are some of the problems that blockchains have when we want to build out a solution? I remember when I first started getting into this industry, one of my board members said, it's garbage in, garbage out. So if I'm going to create a data hash of an apple and put it on a chain, well, no one is going to interpret what this data hash means. So effectively, I'm just adding some numbers and letters on a blockchain. So that's not really good. Or I don't want everyone to see my business data on a blockchain. Other people, they don't understand what information is on a blockchain. Maybe I do want a data hash, but the third party, they don't know how to leverage this data hash, how to work with it. And there's other problems too. We try to think a lot of these. And I think the last question is always too, I want to see how others are using blockchain. That's always something we always see from the foundation, which then kind of goes into the world of thinking about standards. of application design, as a lot of thought goes into these standards from at least a certain group of people that can be leveraged then by other third parties. Another cool concept here, I think that's important, it's a very, very old concept as well, for digital-based interoperability. And basically, this is thinking about the quality of a digital data record and what level of accessibility is there provided by someone else over the internet. And you know, if we start off with just a PDF style document or a data hash by itself, it can be just read-only. And this goes up all the way into you know, JSON linked data, where you can actually parse this information and like have softwares interact to kind of get a result almost on an instantaneous basis. Because it's not just ourselves as human beings that's going to be looking at blockchain records or trying to read a data hash. It's going to be a software program that we create. But that, again, has to be based off of some sort of data standard that allows us, all of us, to figure out ways to structure our data to further our communication. And yeah, that's where W3C standards comes into play very heavily. And we're not just thinking about W3C like digital identity, as the next person in our workshop will talk about, but any sort of data schema that exists can be considered a data standard. And so some of then the problems then that we want to solve is, okay, if all of this exists in the Web 2 space, what do we need to do to bring this into the Web 3 world? And how does that change the way that we design an application for enterprise? And so with Cardano, something that's very interesting here is then how we deliver on-chain utility. And this is all with one feature, which is called transaction metadata. And transaction metadata is basically when you have a total transaction size, that's a certain number of bytes, and that is going to say that I am having a payment originating from this address, and now I'm sending it to that address. And there's data bytes for that. But in addition to this, you have custom data fields. And that custom data field is really what enables all on-chain utility. And we can think about describing a payment. We can think about adding an info memo to a message. And so on Bitcoin, you have 45 bytes to around 65 bytes of data for a transaction. On Ethereum, you have 70 bytes. And on Cardano, you have 16,000 bytes, or 16 kilobytes of data. Now, part of that, people say, okay, well, that's a lot. But what that enables in one transaction is that we have a lot more flexibility here. The reason why it's a lot on Cardano is because in a transaction size, they're also considering the size of entering a smart contract into a transaction. And so the first smart contract of Plutus on Cardano, that used to be by itself 4,600 bytes of data. So people, when they were thinking about transactions, they were thinking about it in this way. But you can also think about it in just the data record way, where it's like, well, if all I'm going to do is leverage a blockchain to make a data record or create an asset, then actually I have a lot more flexibility in the descriptions that I'm going to be including here in this record. So for example, a data hash is still 65 bytes of data. But now, if I have 16,000 bytes, well, what else can I add to this data hash to make it more usable with a third party? How can I have more components to solve this garbage in, garbage out problem and actually bring more transparency and usability on-chain because people are interacting with this data record? Clear? Okay, great. And so here we kind of have this list then of what we consider like core enterprise applications for vital features and components. And I'll kind of go through this. But for an Apple, we would most commonly like to start with some sort of trusted digital identity solution that connects us to the farmer or the Apple company. We also want to have digital signature authentication. We want to be able to know that for a data hash, is there some sort of signature that we can authenticate that says that this is the actual data record that was made by myself, Jeremy, the farmer for the Apple. Data hash validation then is an extra process to know if we can decrypt the data hash, which often includes the use of a digital identity component. Integrations with off-chain code storage is very important. Mainly here, it's because what we're looking at is a process for authentication. And for authentication, it's saying that we know that anyone can use a blockchain, and we know that anyone can add data. And if there's two digital apples existing, which one of those really came from Jeremy's farm? And do I have a way of confirming this because I'm interacting with the on-chain data record itself? And so commonly that involves checking then your data that's stored off-chain. And then commercial data standards. So the approach that I'm making, am I setting up the format for describing the Apple? Is this done in a way that is scalable outside of my specific use case? So outside of my farm, do I care about my country level information, or do I care about the region or the whole world for how they are reporting on data? Third-party verification and Explorer presentation, we will also kind of get into a little bit. Now, you may be thinking about more features, which is great, but for myself and many of us at Cardano Foundation, we think that including everything, all of these components, into one data record is very powerful to bring out the benefits of using blockchain technology and the way that it has been designed. So here it is, just shown again. There isn't much new information on here, but I mean, personally, for me, this has been like a 4-year journey of getting to this level of clarity and thinking about enterprise traceability. I'm not sure if anyone has a question just yet.
Would you use the person who produced the apples information and then produce a date of when it was actually delivered in a separate model, or how would the date fit into it? How do you see that?
So yeah, apples can change, and dates surrounding the supply chain of an apple may be different. Is that the way?
That's right.
Yeah, I mean, so again, I think it all comes down to, are we able to interact with any sort of off-chain code that checks the information that is stored on-chain, right? Because if we're saying that something's on-chain like September 15th.
Yeah, no, because then you have to create a record for each batch you transport. So depending on how many batches, if you've got a truckload, or if you've got a case, or if you've got individual packed. So the scenario is, I've got some apples, they're going to go off in 6 weeks. I'm shipping them. Do we do a record for each apple, or do we do a record for the whole batch? How do you see that?
Okay, yeah. So your transaction frequency on a per product basis, I think one of the things we need to look at is how granular do we want the traceability solution to be? And sometimes the giant batch of apples may be all that we really care about itself. Other times you may want to have the uniqueness of one product and have that supply chain be very much traced. And it comes down to the value of this product or this apple, and the overall cost of implementing the solution. For documents, this is always something very singular, right? So if we have like a shipment document or some sort of trade document, that will still cover a certain bundle of goods. I can kind of show you a little bit later on.
No, I would just think it's perishable, so it's got a different scenario from if you're shipping good things that are not perishable, then it doesn't matter.
Okay. Any other questions? All right. We do think a lot about data batching, and the reason for that on our side, even when it's perishable, is because we want to figure out what is like an economic use of blockchain. But sometimes it's also wanting to know on why are we using this blockchain? So what is the module involved for what we're looking to verify with information on the blockchain itself? So, but these would still kind of be some of your criteria list that you would go down to look on to say, okay, well, how specific do we need to be on each individual apple, or can it be something that we're applying to like a broader group? And I'll discuss that here with a project that we have with the National Wine Agency, which is kind of a pilot program that we're doing of 30 wineries in Georgia and 100,000 bottles, where we're doing the traceability of its source of origin or its provenance data. And here is actually where a lot of for the 100,000 bottles, that does not mean we do 100,000 transactions, but we try to get more granularity onto each shipment of wine, because that wine shipment is the kind of commercial data that we're aiming to follow and verify as accurate. And part of that then is we've developed this supply chain data standard, which is called CIP 1904. And here with CIP 1904, this is very much focused on two major components. The first one is on-chain verification data, and the second one is the authentication process. And so Joseph Duran was very much known as an American engineer and manager for quality management and putting forward new systems for operational efficiency. And for this supply chain data standard, what we're looking at is basically any industry where you may want to have a certification system that you wish to have verifiable records and kind of ease that process of third parties to access and confirm this data. So it all starts with the provenance data collection process, and this is the off-chain side, which is, do we agree on how to describe our apples? And now it's do we agree on the supply chain data for the wine itself? And also then the certificate data. So on the right is called a certificate of conformity. And this is the official trade document that is used whenever a bottle of wine in the country of Georgia is sold domestically and to export markets. The other reason why we've leveraged this data standard is because that was following what's called OIV industry data standard. And it's a supply chain data standard that is being used today in over 50 different countries. And so what we're saying here is that just the commercial data that we're using to describe the bottle of wine, this is already an existing data standard that's being used widely. And then also, it also allows us easily, when we need to think about parsing this information, or making it machine readable that other third-party systems, they can commonly plug into this data standard. Secondly, then, is looking at Explorer verification. And here, I'll try to dig in a little bit deeper to the kind of components that we do on this. One of them is on the data hash. We actually have what's called a content identifier validation, also known as a CID. And here, this is saying that what you're able to do is actually, you can have two different parts of a data hash. You can have one part as an identifier of the data storage location, and then the second part being the data hash itself. So as a content identifier, if I were to have information stored on AWS, and then I move it to like my own server, then the content identifier can change. And if I'm uploading information, and if I'm not using the same data server, you can be alerted that is kind of has differences there. You have digital identity authentication, and here this is looking at a process of validating the authenticity of public keys. For us, digital identity authentication is just a standardized process to say, for any sort of digital identity system that's used, do we have an agreement on how you do this verification? And the same thing for signature verification. So when we can kind of combine these three components into place, what we're able to do is to kind of confirm on-chain that the data that represents this apple or this bottle of wine, it combines all of the above for the identity, the data hash, and digital signatures that relates to a very specific off-chain data storage layer to kind of prove that we're looking at the authentic on-chain data record. Does that make sense? Okay. So what we try to avoid is between anyone who's also using the blockchain, and if they follow the same approach, if they make the same data record, you want to be instantly able to determine which one is the correct data record that you're interacting with. So some of these times the problems kind of involves like NFTs. And if I make a digital asset of any kind, I can copy all the existing information. And so by able to confirming the off-chain data storage layer with a digital identity and signature component, we really kind of reduce the risk to fake the digital record side of things. And if we bring that up to a larger level, it kind of looks more like this on the Explorer side, where, as I said, with the parsing this information, we're now able to do instantly some verification on the off-chain data layer. So the content identifier or the data hash itself can instantly be verified as being accurate. And we're also able to then visualize some of the on-chain code and pull in onto the Explorer level that does represent this bottle of wine.
So in practicality, how do you ensure that whatever is off-chain data, like how do you like 100% like make sure that never gets tampered with? Like I'm assuming, like, again, I don't know how these wineries work exactly, but I'm sure they're keeping like datas on their local computers, or I don't even know, like maybe registers or something. So how do you, at the end of the day, really ensure that it hasn't been tampered with by, say, let's an employee or anyone else?
So how do we ensure the data has never been tampered with? Well, we cannot. What we can ensure is if this data has been tampered with. And that's more of the process of wanting to use a blockchain, is if something has changed, I want to know. And therefore, I can have an alert that says, well, hey, something is not correct in what I'm seeing. And now there's a process that we need to go to say, well, can we somehow get back to the original data set that we agreed to? Maybe I have that data already stored somewhere else, like in a backup, right? And for a module like this, you can always then say, okay, well, if something needs to change to that data set, let's all agree on the latest version of that, and we'll update this record on chain, and then that's the record that we will point to for all third parties to interact with.
Right. So at the end of the day, the goal is to ensure that all parties agree on whatever data gets used. Correct?
Yes.
Okay. That sounds good.
Just the slide before this. You've got 3 entries. You've got the wine. At the end, it's the winery, where it's come from. Then it's the Institute of Wines, and then it's, I can't remember the first one, but there were 3 of them. Yeah. Then you've got the actual server. To me, it makes sense. You've got this is just from my point of view. You've got 1 and 3. What's the use case for having the second one? Because surely the signature for the keys for the third one would be enough, or is that what's the use case for that? Just out of interest, really.
The use case for the digital identity?
No. I understand all the keys. It's just a question. You've got an additional key for the actual validating the authenticity of the National Wine Agency and wineries. Well, I'm just wondering why would you put that on chain when you know where the signature of? Yeah. Well, the third one is another signature. Why have you got two signatures? Maybe I'm misunderstanding something. This is more of a general interest. Maybe we could talk about it afterwards. Or.
Yeah, let's try that. I might explain your question.
Yeah. Don't worry. We'll talk about it afterwards.
Yeah.
Do you also validate the product authenticity during the entire supply chain, especially for the wine case? Because I'm assuming it offloads, onloads at a different point of services, right, before reaching to the customer. Other than verifying with probably content identifier, is there any way you also validate that the content of that bottle is actually authentic?
So that's the purpose of having kind of like a winery identity and a digital signature, is that for each stage of the supply chain where we're collecting this information, first we want to have like a very specific data backend where all information is being stored, and then we need to have some sort of confirmation that says, for the entity that is uploading this information, do you confirm that it is correct, right? Because there's only so much that we can do as like a back-end data services, right, to do that confirmation, unless we like go everywhere to that location where the data was collected and verify it ourselves. But then what you can also have is in that auditor role, right, as a third party who has the same process of like, representing their identity and then representing their signatures to say, hey, I have also done that confirmation that confirms that this is the correct product.
It's all to the data, right? There's
Yeah.
no way to authenticate. What is this? Is a water and not a wine. This is water. You know what I'm saying? Somebody tampered the actual content of the bottle and not the data, because you're probably scanning, I believe, some barcode to get all the content from the bottle, I'm assuming.
Yeah.
Right? So, but what about the contents in the bottle? Do you guys have, I'm not saying if it is a part of a process, but I worked something similar on that in terms of petroleum. So those guys do a different way to validate whether there is a water within these tankers. Somebody tampered these and they kind of find an alert.
Yeah, I mean, so I think that's a really, really great question. And part of that is also understanding at first our solution that we develop, it covers what degree of scope, right? Maybe we're looking at like this covers 80% of all problems that exist today. It's also how are you able to collect that data? So when it comes to like a barrel of oil or some other product, you may have sensors that are installed already that can be activated that says like this has been opened at this date. With the wine bottle, you're not going to have that, right? Unless it's a very expensive bottle of wine that tells you that this has been opened before. Sometimes you have systems in place that do this already, but then it's about, is that connected to some database that we can then reference with a blockchain transaction? I mean, so it's a very, very good question. And part of what I like to demonstrate here is, well, okay, is that an edge case? And is that a case that a particular development team can work towards to figure out how to solve that? Because we're already proving certain core value propositions of the existing solution. And what I wish I could do is be able to focus a lot more on seeing how to solve like problems just like that to increase the level of coverage. Question here? Yes.
Yeah. The main purpose of a blockchain, especially smart contracts, is to bring the transparency in the data and remove the chances of somebody can tamper the data in future, right? Bring scalability, transparency to the data, bring trust among strangers. Now, when you mention off-chain the data, why do we go to blockchain in first place then if we can actually store off-chain and verify from off-chain data whether the blockchain has the correct data or not? I mean, why are we going to off-chain if we need blockchain at first place for the same purpose?
Good question. So on the blockchain side, we do have this tamper-proof immutable data record that you can never change that, but the rest of the world can be changed. And in those cases, when we want to know if the data has ever been changed, we can refer to the blockchain record itself or what data is on-chain. So commonly we think about that as like on-chain verifiable data records. And in addition to that, there may be sensitive industry data that we don't want being stored on a blockchain itself, but we want to have some sort of representation of that data. And that's the only piece of information we need to see, right? And this may be very much a complementary system to where, okay, for 80% of the use cases, if I'm looking at what's on the blockchain and it's showing me these check marks, I don't need to see further information. So now I'm speeding up my audit process to confirm that this is all accurate. For the 20%, I've been able to identify, well, hold on, there's an issue here, and now we need to go through some other process to kind of confirm the authenticity of that part. And so how do you increase the level of effectiveness by using a blockchain? And that's kind of the purpose here of discussing the integration of using different types of data hashes, digital identity components, digital signatures, and off-chain layer data authentication as required. But if you're not connecting what's on a blockchain to what's stored off the blockchain, then effectively you have no real economic link to the actual source data.
Thank you.
Thank you. So I would add one more argument to your response. The reason why we are not storing everything on the blockchain is costs. So the actually we don't need to store the data on all the nodes when we have this on one-way function, one-way relation from the off-chain data to the hash. So I understand that content identifier is actually the hash of the data. If anything happens with the data, even a byte is changed, it will result in a different hash. When the hash is stored on the blockchain, it's immutable, so it will be not verifiable. It will be a conflict there, and we know that the off-chain data has been tampered with. So this is the tamper-proof solution, putting the hash on the blockchain. I understand that we use digital signature for for signing the proofs of the data. So I, as an entity, I am guaranteeing for this data. I am guaranteeing that this batch passed to this point of the supply chain, for example. And I understand that we use digital identity to link the public key identifier on the chain with the real world identity, an entity from the real world. What I did not understand, and that's my question actually, is how do we link that off-chain data with the real product, with the real asset, with the real bottle of wine or something? How do we have this link?
Yeah, so that's often done through some sort of physical identifier, right? And if we're having these type of static transactions to where we're not actually adding wallets out on every product, but we're bringing accessibility to these data records, what we're then able to kind of demonstrate is that if I'm looking at a product, like if I'm looking at, it depends on what is human readable as well, right? But let's say I'm looking at this product of a water bottle that does not have an expiration date, but for fun, we will say it does. It expires tomorrow. And if the expiration date is also on the on-chain data record or shown here as the off-chain data that's being pulled and displayed, I can kind of check to see if what content is shown here, if that's the same content that is shown on the data record.
In this case, what stops me as a, let's say, a bad actor to counterfeit a bottle of wine, just copying the original one that I bought? Just creating another one with the same data that I see and can verify with my own eyes because I have the real product, and sell you the fake one.
Yeah, and I think, again, that comes down to, if there's a value to try to create fraud, people will try their best to create fraud. And, so what is the level of quality for that physical side? So in the Georgian wine case, we use a very advanced type of QR code that you cannot tamper with. You can read information, but you cannot access and write information onto that QR code. And there are other such components today, such as NFC chips, that have that same level of sophistication depending on the product at hand, right? And, it's even today, with all the technical solutions we have, the counterfeit market just continues to grow. So this is not like a theoretical question you're proposing here. It's a real world issue. And what we're all aiming to do is to figure out ways to start taking back some of that market share of what is counterfeit and proving to consumers that this is actually the real good at hand. Yeah, increasing its value and more. It also comes down to user experience too in some of these cases. So it's a very general question, right? So if you have something very specific, happy to discuss that. All right. Any other questions? I think not. But again, what we're able to also do here is not only check what's verified, but then also what is invalid. So if you do have someone that is copying everything on a blockchain or on a physical product, they may not be able to copy the information that is stored off-chain but being referenced on-chain. So that off-chain data storage layer connection, can be a very powerful tool for many use cases where we want to confirm authenticity for it. And what I'm showing you here on viewing off-chain data, viewing verification of certificates, viewing to know if this is an official winery by the Georgian government, this is not done as a product. This is being implemented on an open source explorer and on the infrastructure layer for how to use a blockchain. And so we're seemingly having a conversation in the front two rows on products. And I'm demonstrating the capabilities that exist as the infrastructure. And so when it comes to these other use cases, that's where this really becomes powerful, is that now we actually have a channel on thinking on how we can go about solving those very particular issues, but doing so in a way that's not done in a black box. We're doing it in an open way where any third party, if they're able to follow the same procedure that you make as a standard, they're also to come to the same conclusion as you as to whether that data really is accurate and really is authentic. And for me at the Cardano Foundation, this is really kind of a lifetime achievement, because what exists beforehand is nothing like this for interacting with information that's stored on-chain. That has been done with complicated third-party tooling, and it's been done with layers and layers of other software systems that's not actually part of the blockchain itself. So the whole conversation is going back towards the same conclusion, which is, how do we increase the operational use of on-chain data records? And when we think about the enterprise world, there are so many different use cases that exist. It's really hard to have that one-size-fits-all solution, right? So we very much then try to go back to thinking then, does our building blocks that we have, does it cover a large enough amount of the problems that are out there? And, so yeah, I guess that brings my last question, which one person answered the active poll first time. What level of innovation do you believe this solution brings? And for me, I believe that it's quite innovative in the overall quality of using blockchain as infrastructure. And with that, I'd like to say thank you everyone for joining, and I'll stick around for a few minutes in case you have further questions.